Hello everyone, good morning, good afternoon, good evening. I hope you are enjoying HashiTalks and all the amazing presentations. My name is Marcelo Zambrana. I'm a software engineer at Microsoft. I focus on cloud technologies, configuration, and infrastructure tools. I am a big fan of automation, everything related to DevOps, and of course, open source. My talk today is about how to make your first contribution to the AzureRM Terraform provider. My goal with this talk is to make it easy for people interested in contributing to this type of projects to take the first step. It is also to help understand the process behind it. Especially when you are just starting out, this process could be a bit intimidating and complex. But again, I'm here hoping that after this talk, with the tools and the code I'll provide, it will become a little bit easier for developers to take this initial step and have a better understanding on how everything works. I don't have a lot of slides, but the few I have, I'll try to go a little bit faster so I can spend more time on the demo and the code I have prepared for you. All the code I'll show today will be on my GitHub account on a public repo. Even during the demo, I'll show you how to create everything that is needed from start to finish. So let's start. Let's just level set and understand what Terraform provider is and how it works, a very high level. So if you're watching this, you probably have used Terraform before. You have written some infrastructure as code multiple times. You have used Terraform to plan, apply, and destroy your infrastructure multiple times. You've done that with any number of cloud providers and services, right? And you may wonder, how does Terraform know how to provision all this infrastructure? I think there is more than 4,000 plus different providers in the registry right now, so don't quote me on that. So how does Terraform itself know how to manage all these resources? Well, the provider is the secret ingredient. Under the hood, Terraform provider acts essentially as a plugin. It communicates with Terraform core over RPC and presents the resources and data sources that you can manage with the provider. Terraform providers like Terraform itself are built in Go and use a client library to handle communication with your target APIs over HTTPS. This client library takes care of connecting to the API, authenticating your requests, handling common errors like connection issues, and converting the data it receives into usable format. So once the API data is processed, the provider uses standard Terraform libraries to send the information back to Terraform, such as the resource details, its state, and the results of operations that have been performed. Basically, here's what happened when we created your cloud resource and the results of that. So again, this is a very high level. Well, with that high level overview out of the way, let's take a look at the project structure. As you can imagine, projects of this magnitude are complex by nature. But understanding their structure is something I recommend doing as first step. This project has several folders, like any other project of this magnitude. But I think these are the most important, especially if you are just starting out. The first one, examples, are where all the examples that are in the official documentation are located. Every example that is in the documentation is in this folder. Then we have internal, and within internal we have services. This folder is where all the resources and data sources that this provider offers are. So if you're going to make improvements, changes, this is where to look at. Finally, we have website, which is practically all the official documentation that we see when we go to the provider's official page. And if you see, all major cloud providers follow the same folder structure, so it should be easy to just move from one to another. I think that when one is just starting out, contributions can be of three different types. That's why I focus on these three folders. You can improve, create new examples in the documentation. You can fix, create, or improve providers' resources and data sources if you want to make enhancements. And finally, helping by improving the documentation. As you can imagine, these projects are constantly evolving all the time. And sometimes the documentation is left behind. So helping in the documentation is always welcome. And again, as I was saying, this folder structure matches pretty much all Terraform providers we have out there. At least the general folders, like examples, website, and services are always there. So you can take a look at those. The next step is to understand how the provider interacts with Azure in this case. As we mentioned before, the provider uses client libraries, and these are some of them. The first one, Go Azure SDK. This is an opinionated Go SDK generated by HashiCorp for interaction with the Azure Resource Manager. Next, we have the Azure SDK for Go. This is also for interaction with Azure Resource Manager, but this one gets generated from the Swagger files within the Azure REST API specs repo. Next, we have Hamilton. This is to interact with Microsoft Graph and to obtain authentication tokens using Microsoft Authentication Libraries, or MSL. Last but not least is Giovanni. This is for interaction with the Azure Storage Data Plane APIs. And we're going to focus on this last one in our demo to make some updates that happened recently. So as you can see, these are some of the client libraries the provider uses. And other providers could use different kind of libraries, but some of them are based on authentication, security, and to interact with multiple data planes. Now, the last thing before going into the demo is to understand how we can compile the project, create a binary, running some tests, and of course, debugging in case it is needed. Creating a binary is super simple. We just need to do a make build, and that takes care of everything. Once finished, the library will be copied to this folder, gopath/bin. The same to run unit tests. We just do a make test, and all the unit tests get executed. Most of the provider tests, though, are acceptance tests, which create real resources in Azure. Something to take a note, because this could be expensive depending on the services you are testing. It is possible to run an entire set of acceptance tests by running make test ACC, and that's going to take forever, but it will run every test that they have. However, it is likely that, and most recommended, that you only need to run a subset of them based on the service you want to test, and this can be done by running the command as follows: make ACC tests, the service you want to test, and you pass as an argument the name of the test you want to execute, and a timeout if it's needed. And again, this is because these tests create real resources in Azure, and this could be very expensive. Now, to see more information when you're debugging, you only need to enable this variable, t_log, and you can set it to info or debug, depending on what level of information you want to see. And the rest will be enabled either when you run any Terraform command or when you run the acceptance tests. Really easy. Well, before going into the demo, before we start, here are some conventions, aliases that I use. I don't like typing because when I type, I make a lot of mistakes. So I try to optimize that part. So you will see me using some of these aliases as I go through the demo. Okay, demo time. So I want to start with my dev environment. I am a big fan of these possible dev environments, mostly because when you want to work on these kind of projects, you need a really beefy machine with a lot of resources, CPU and RAM. So what I do is I automate these environments using Terraform, of course. And as you can see here, I have one here with my VM, some disks, public IP, and some security groups. And all of this is done using Terraform. So whenever I start a project, I just create a VM, I clone the repo, I do my work, run the tests, I push my changes, and then I destroy my environment, right? Mostly this is because, again, these projects need a lot of resources, especially when you want to run tests and compile and generate the build as we're going to see it. So I like to create these disposable demo environments with a lot of resources so I can do it faster, and then I just destroy them. Again, all of this is going to be open source. It's going to be my repo. If you want to create one, clone it or fork it, everything is there. And the cool thing is, the team behind the provider has great documentation. Has these developer requirements, how to set up your environment, everything that needs to be done for Windows, Linux, with all the steps you need to do. But I got those steps and I just automated those using Ansible. So as part of the post-deployment configuration, I just ran Ansible to make all these configurations that they do require to build and develop the provider. all of these are part of my Ansible configurations. So everything is automated. With that, and again, everything could be personalized depending on what type of VM you want to use, all that stuff. And there are things like, for example, it sets the go path, as the documentation says. Here now it's redirected to my repo Go projects. And if we take a look at that folder, let me just copy this command. As you can see here, I like to have this folder structure. Source, github.com, which is where the repo is coming from. HashiCorp is the organization, and Terraform is the name of the repo. Right? This could be, instead of github.com, could be your GitHub Enterprise server. Organization could be something internal that you have, and the name of the repo. So I like to keep these the way it's organized. And they do also suggest the same in the documentation. Now, if we go to that repo, just make sure I'm going to go into the repo folder. And I already have a branch here that we're going to be working on. As I mentioned, we're going to focus on the Giovanni. Right now, they have an update that we need to migrate a new endpoint they have. And as you can see here, I have my own copy of the Terraform provider. So that's, again, that's another requirement. You go to Terraform repo and you just get your own fork. I already have mine. That's why it says you already own a copy of these. So make sure to get your own copy, and then just once you have yours, you just clone it. If I go to my repos, and if I go to Terraform, basically I just clone it. Okay, so moving on. So what we're going to do, and probably at this point we can see the same repo here in VS Code. As you can see, here are the folders I was talking about earlier, the examples folder, where you can see all the service and the examples they have for each service. And again, this is a great way to start. You can just update one of these examples that is out of date, or create new ones based on the new updates that they have all the time. They also have internal services, and as I was saying, here are all the resources that this provider has. Like we have API management, we have automation, we have compute for VMs. And the one thing I like is that they have this naming convention like data source test. So you know these are the tests related to that data source. And just resource is just the resource for that specific service. So I like that. So it's organized, and the naming convention is standard across all of them. And the other folder that we saw, it was website. Again, these are just the documentation, the official website for all the data sources, and the resources that they have inside here. So this is all the documentation about all the services they have. And again, this is another great way to start, because you can update the documentation as they keep updating and getting the new resources into the provider. But with that, I'm going to focus on one issue. The one that we were saying, it is about updating the Giovanni endpoint. We're going to migrate to a new repo that they have. So for that, which is going to be a simple change, but it's going to affect a lot of files, because we're going to update a dependency on a vendor repo. So here, under the internal folder and services, we're going to look for the old value. I'm going to just Control-Shift-F. And I know that the old value is this one. And actually, we're just going to search for it. We can open in the editor, and you see if it found 92 results in 53 files, which is nice. And I just need to update this endpoint. As you can see here, it is using this Giovanni from this repo, but I know we need to update to this new endpoint that they have. It's a simple change, but again, it's going to affect a lot of services. As you can see here, it's going to affect Kubernetes, virtual machine, storage account. This is normal because, again, as we said before, Giovanni is a client library that manages the storage data plane API. So yeah, it's going to affect a lot of storage resources and data sources. So I'm confident about this change. It's asking me, yes, I'm going to replace all of them, just changing one endpoint. And as you can see here, it did a lot of changes. We go back to the terminal and we do a get status. You can see that all the changes are here. All these files were modified. Whenever you do these kind of changes, if you're familiar with Go, you run git mode ID and git mode vendor, which is basically just clean the old endpoints and update the new ones and getting the new information about the new endpoint. So we do this. This might take a minute or two. mostly because it's cleaning everything about the old endpoint and getting information about the new endpoint that we're going to use. And this should be fast, depending if it's the first time you're doing it or the second time. Right now, I think it's the first time I'm doing this VM, this dev environment, so it might take a minute or two. But it should be fairly quickly. As you can see, it's moving along. It's getting all the, at the same time, it's getting information about the new libraries that it's using. As you can see here, it keeps moving. It finds a new module. That's the one we updated, right? And yeah, we got an error. So I think, yeah, this was my mistake. I think I replaced the wrong thing, as you can see here, yeah. So this should be an easy fix. We're just gonna search for this string. And we should have the same amount. Right. Now we need to replace this with just one. Giovanni. And we're going to replace all of them. This time we should be good. And we click here. Okay. Now we do it again. This time, yeah. Now with this there. Sorry about that. That's what happens when I type. I make mistakes. Okay, so it finished. This is good. This is a good start. So the other thing I like to do is whenever I make a change, and you can see here, it was just replaced, but as you can see here, it deleted the old reference and added the new reference for the new endpoint. So as you can see here, it's a lot of changes now because it is modifying the files and it's also deleting the old ones and adding the new ones. So I like to do this, at this point, I like to make a build. As we said, it's just make build and it's going to do it. So if you run this and it works, this is a good step that you didn't break anything, right? So say that if it compiles, it works. So let's give it a try. And for this type of use case, I think it's useful because, again, it was not a big change. It was just replacing a new endpoint and getting the new files and references. So we should be good. But whenever you make a change, especially personally, I like to make a change, compile, and see if it still works. And also it's helpful to run the tests. I'm going to see later. But now we're just going to generate a build. These, depending on the machine you have, might take a while. That's why I like to create these possible VMs, because I can assign 32, 64 more RAM, faster SSDs, and nice CPU, so this process is faster. Because otherwise, if you're doing your laptop, they only have 16 of RAM, 16 gigs of RAM, and not a lot of fast SSDs or CPU. Yeah, probably it's not going to finish, or it's going to take a lot of time. So that's why I like to create these virtual environments, which are heavy, beefy, and have a lot of resources. So this might take some time. Okay, so that wasn't that bad. As you can see, it finished, no errors. That's really good sign, and it only took 4.5 minutes on this machine. So that's pretty good. So we know we can compile after all those changes. But one thing I wanted to show you is now, if you see, this has a lot more folders now. The Go projects. Before it only had source, now it has bin and package. The good thing about this is that you can see what is in there. Let me just copy this one. As you can see here, this is our brand new provider that we just compiled, right, just minutes ago. So that's really good. So we know we can create a new build. So that's great. But now let's run some tests because we make some significant changes and we don't want to break anything, right? Make sure everything is still working. On top of that, we can create that build. We also want to make sure the tests are not broken. So as a sample, we want to execute one of the affected files that we know we got by the change we did. So we're just going to look for, I think it was related to storage. So if we go look for that file, we're going to go for this one, which is test.go. It's under service storage. So as you can see here, we updated these. And I think we're going to run this test. It's just the first test, just picking the first one here. So, and this, again, this is going to take some time because it's going to create the actual resource in Azure. We go back to the terminal. This is a command we saw on the slides. We are going to do make ACC tests. The service we know is storage. And as an argument, we pass the test we want to execute and a timeout in case we need it. It should be a timeout. I'm sure we're not going to hit it because, again, this is just a storage account. Usually those create pretty fast. And yeah, they are not that expensive either, right? Unless you store something big. But for this test, should be really good. So just getting the first test, getting the command, and let's let it run. So again, this is going to compile. It's going to check for the specific test, and it's going to start running it. At some point, we're going to see, if we go to the portal, let's see if we can see it now. Probably it's too early to see it. But again, right now it's running, is going into your Azure account, and it's going to run Terraform against that specific account, this specific test. So we go back here, probably still too early. Sometimes the UI takes more time to refresh than the CLI. That's why I like using CLI as well. If you can see here, it already started running the test. Probably now we're probably going to see some, yeah, here's the resource group part of that test. If you see here, it's just created. If we go to here, at some point we're going to see a storage account here as part of the test. It's going to create one. Now let's see in the command line. Yeah, it's running this test, which is nice. Go back here. Yep. As you can see, here's the storage account that you created. And the good thing about this test is that once they get executed and they are successful, they clean everything, which is nice. And really convenient because, again, these create resources in Azure and those are expensive. So once they are done, just cleans everything. So that's great. Let's let it run for a minute. We can go back to the code. And as you can see here, as I said, most of the tests are acceptance tests because you need to test pretty much every scenario for this provider. And as you can see, there are lots and lots of tests. So if you want to create add a new functionality for an existing resource, you also need to create a test for it. If there is a new property, a new SKU, a new configuration, so the recommended approaches on top of the code changes also to create new tests. And they have templates for pretty much all of them. As you can see here, there's the internal Terraform code is going to be executed, right, when this test is running. And we go back, as you can see here, these are great, it passed, everything is fine, everything's good, we didn't break anything, which is nice. And if we go back to the portal, probably we won't see that resource group anymore because it took care of it, right? It cleans everything, which is really nice. That's good. So now we know how to compile, get a binary, we run some tests, and now we're going to try to do some debugging. Sometimes when you make changes, you want to see more information about it. You want to debug if something is not right. So as part of my dev automation, I also have this folder test provider. And if you can see here, I only have one file. That's just basically just creating a resource group. Right? It's not that complicated. It's very simple. But this will allow us, for example, if I do Terraform validate, as you can see here, you got a warning because it's also configured to use this internal binary I have here. As you can see, provider development overrides are in effect. As you can see here, it's getting the provider from this location, which is where our binary was created. And it's success, it validated, it's fine, so that's good. But how about if I want to enable more info about it? So again, I just enable this flag, and I run the same command. These logs are enabled, and now every time you run a Terraform command or run acceptance tests, you're going to see the information. And as you can see here, you get a lot more information, a lot more verbose. It depends on how much information you need. But you can see here that the plugin is getting the location from here, which is our local provider. It's not getting from the registry, it's getting from our local folder, which is what we want, right? And if we wanted to, we can do a Terraform plan. And again, it's going to do all the process. Again, it's going to work. If we're going to go the extra mile, we can do Terraform apply. A lot of information about what it's doing, right? It is getting the provider from our local folder and start creating. And it's doing a test RG resource. This is pretty quick. If we go here, here's our test resource group. And we can also do a Terraform destroy. And again, all the information about what is happening behind the scenes. So that's great. So we were able to compile, create a build, use that build internally to run tests, and enable debugging to see a lot more information in case we need it. And also run the acceptance tests, at least one of them right now. But yeah, because if you get all of them, it's going to take forever. And I only have 30 minutes. So that's good. So the next step, of course, if you go to, let's go repos. As you can see here, now if we do a git status, we see all these files. So what I like to do is I like to split my commits based on what I did. First, I like to add all the changes and modifications. If you see here, all whatever I deleted and modify are in just one commit, and the new ones are still here. And I like that because I have to I like those commits to be in those changes in different commits, so it's easier to cherry pick if it's needed. And that's my personal choice, though. And also, it's not a huge commit with everything in there. So I'm just gonna create one commit with I updated the vendor. If you see, we do another git status. The only thing we have is the extra files we got. Those could be easily added. And we'll do like that. And we get the status, all the new files that were brought by when we got the new endpoint. So that's really good. So if we have those, we can do just git c new files from new endpoint. That's great. So if you see here, everything is clean, everything is ready to go. And the last step is we can just push these files. At the end, we want to merge this into the official branch, right? So with the git push, I have a password on my key. Oops, that's why I don't like to type, because I make mistakes. So everything was pushed to my fork. And if we go to my GitHub repo, it already detected that I have a branch if I want to merge. So I can always do a compare and pull request. And here we have it, right? Easy. There's a template you need to fill out. All the things we have done. We can easily do that. We can just check the PR checklist. I follow the guidelines. I have checked to ensure that there aren't any pull requests. I check my changes close to issues. I know there's an issue about it because I created it. I haven't done documentation. Probably I'm gonna do that in a different PR. Use a meaningful PR title, right? And I have added explanations to one of my changes. Yes. So basically, we need to go through all of these. I haven't written new tests because I haven't created a new one, but I ran those. I successfully ran the test. As you saw, this is not a state migration, right? My submission includes test coverage. Usually, what I do here is just copy the output of the when I run the acceptance tests. I just copy and paste that output, so at least there is some proof that I've done that, right? And you do that and just create pull request. And as you can see here, these are the two commits I created, one for the update endpoint and for another one for the new files. As you can see here, there are more than 232 files exactly that have been updated. So, and that's pretty much it. Okay, so I think that's good for a demo. Well, I kind of cheated on this one because I already sent this PR and I didn't expect they were going to merge it so soon, so they are awesome. So as you can see here, I have this issue that I created, which is Giovanni, migrate Giovanni to the new endpoint. I was testing it to prepare for this demo. And I submitted the PR, and they are so fast and awesome that they merged it before I could record it. And as you can see here, this is the PR that I created, and it got merged before I could record it. So that's how awesome our maintainers are. But yeah, but the process is the same, right? You get your fork, you clone it, you make the changes, you compile, you run tests, and then you test it, you enable debugging, and then you submit a PR, and it gets merged. Perfect. So I think this is a good time to go back to slides. Okay, so going back to slides. So in summary, we saw how to create the project, where the binary is located, and how easy it is to use it. Right? We did a make build, and everything fine, and we got our binary. We also saw how to run acceptance tests not only and only on the service we updated, right? Not the whole thing, just the one we specifically wanted. And again, this is because acceptance tests create real resources, and this could be expensive. And it was nice that it passed at the first try. Yes, usually that never happens, but we got lucky. Finally, we saw how to create, how to debug. We enable more logs to see exactly what's going on behind the scenes. And we were able to use our own binary and see what's happening behind the scenes on that specific binary. And it worked. So again, making all those three, creating a binary, running the test, and even debugging to make sure it's using the one we just created. I think it's a really good process to make sure everything is working fine, and also to make sure your changes didn't break anything. And at the end, finally, we saw how to create a PR, and so we can merge it, merge our changes to the official project. Again, I cannot show it because I submitted and I didn't expect them to approve it that fast. So, but thanks. Some key things I would like to mention are having a dev environment that is automated. I think is at least personally to me is very important. All these projects, as you saw, are huge compared to the average project. They have a lot of configurations, requirements to properly run, build, and debug them. So I think if you automate all of these, it takes the pressure of I did something wrong. Right? I can just run it again, and it always work. And again, having those disposable environments that you can just create one and do your work on a beefy machine with good RAM, SSDs, and RAM, and CPU, you do your changes, you submit your PR, and then you just destroy them. Easy. I love doing that. I've been doing that for a while, and I totally like it. So whenever I find a new project, I just try to automate that development environment with all the requirements. So it's easy for me to just create, destroy. And I keep saying that the best way to test is to build it. If it compiles, most likely it's going to work, right? It's most likely didn't break anything. Might not work the way it was supposed to work, but at least it works. That's why you have tests. Right? Just compiling is not enough. You also need to run the tests. Something very important. Personally, I don't think not all contributions need to be code. That's why I like to focus on those folders I mentioned earlier. There are tons of contributions to open source projects. Could be improving the examples they have. These providers get updated pretty much every week. So having those examples up to date with new resources, new configurations is always helpful. You can also help with documentation. As I keep saying that documentation always gets behind. So having those up to date is really important. You can also comment on issues, validate the issues. You can reproduce those, make comments. So at the beginning, I think you don't have to put pressure on yourself that all contributions need to be code. Eventually, you're going to get there. But I think a good learning experience to start with the documentation, with examples, little by little making more changes as you feel more comfortable and confident. That's why I don't think that not all contributions need to be code related. And again, with this, you gain hands-on experience on real projects. You learn new technologies, new frameworks, new workflows, and you share your experience with others. Like right now, I think that's very important. I always like sharing the knowledge with the community. And that goes hand in hand with impact and recognition. Personally, I like to contribute to tools and technology that thousands, if not millions of people use. Help a little bit. You get recognition in the community. I think that's also amazing. Open source has always been that way, and I like it. That's why I like open source. But some resources, if you want to get started with Go, and that's a great link to start. Go to dev/learn. It's amazing. There is some documentation to the official REST API for Azure, the AzureRM provider. Some documentation about how to contribute, the guides for the contributors. We do have a Slack workspace, so there's a link if you want to request an invite. The AzureRM documentation, and I put a link to the GitHub actions. That's why I use to orchestrate the automation of these dev environments. So it runs Terraform and then Ansible to do all the post deployment configurations. With that, I just want to say thank you for tuning in. Hope you enjoyed this presentation. Hopefully I'll see your contribution soon. All the code I showed today is going to be available on my GitHub account. Please feel free to contact me if you have any questions, comment, or if you just want to say hello. Finally, I just want to say thanks to HashiCorp and the whole team for this amazing opportunity I know it's been probably at this point more than 24 hours I've been working on this, and thank you so much. Every year I look forward to this so I can share something. Thanks everyone, and until the next time, gracias totales. Ciao.